Okay, so in this video I'm going to have a look at the cosine function. And I'm going to have a look at these three here. I'm going to have a look at the cosine of theta, the cos of 2 theta, and 2 cos 2 theta. So I've actually drawn it here, but how did I draw this? Where did I get these points from? Well, let's have a look. Again, I have the x-axis and the y-axis here. On my x-axis I have my angles, theta. So I put in from 0 to 2 pi here so far, or from 0 to 360 degrees. So I put in half of that, which is pi, half of that again, which is pi over 2, and 3 pi over 2, or 1.5 pi here. So this is in degrees, this is 0, 90, 180, 270, and 360 degrees. So let's have a look. I have the unit circle drawn here as well, so I've got 4 main points in here. So I have 0 degrees from here to here. 0 degrees. Now remember, the cosine is the first coordinate here, the x coordinate. So the cosine of 0 degrees is 1. So 0 degrees is 1. So I put a point here. 90 degrees, or pi over 2, the cosine, the first coordinate here, is 0. So I put a point here. 180 degrees, minus 1. So I've gone down to minus 1 here for pi. 270 degrees, or 3 pi over 2. First coordinate is 0, so I'm back to 0 again. And all the way around here to 360 degrees, or 2 pi. First coordinate is 1, so I'm back up here at 1 again for 2 pi. So this is the graph of the cosine of theta. Now this will repeat, by the way, as with the sine function. This will repeat into infinity here along the x-axis and into the negative x-axis as well. So this is a periodic function again, and the period of this function again, as with sine function, is 2 pi. It repeats every 2 pi, same shape every 2 pi. The range then on the y-axis goes from minus 1 to 1, minus 1 up to 1. Okay, so that's it for the cosine of theta here, the cosine of theta. Let's have a look at the second one here, which is the cosine of 2 theta. So what happens here? Well, as with the sine function, everything is just squashed in. So let's have a look at some of these points here. Again, I've gone, instead of going from 0 to pi, from 0 to 2 pi, I've gone from 0 to pi, because I know that this is going to be squashed in. Now remember, from the sine function, the period was 2 pi, and the period for the period here for the cosine of theta was 2 pi. So this is cosine 2, so if you divide this by 2, so 2 pi divided by 2, the period will be pi. That's why I've gone from 0 to pi here. So we would expect the period for this particular one, so this is the period of cosine of 2 theta here, 2 theta. Divide the period of cosine of theta by 2. So divide 2 pi by 2 and you get pi. So this is what I would expect. So let's see, does that work? Let's start with 0 anyway. So the cos of 0, the cosine of 0 is still 1. Cosine of 0 will be 1. Let's have a look at pi over 4. So we want the cosine, or the cos of twice pi over 4. So that's just the cos of pi over 2. The cosine of pi over 2, or 90 degrees, is just going to be 0. Okay, so let's look at pi over 2. So we want the cosine of twice pi over 2. So that's just the cosine, or the cos of pi. The cos of pi, or 180 degrees, is going to be minus 1 from our unit circle. So we're just going to put a point in here at minus 1. 3 pi over 4, so we want the cos of twice 3 pi over 4. So that's just the cos of 3 pi over 2, or 1.5 pi. And we found that from our unit circle is 0. And pi here, the cos of 2 pi, is just 1 again. Okay, so we're going to be up here again. So if you look at this, we're just going to join these up. Let's see, you're just going to go down here. Excuse my art here, but you get the idea. So okay, there we go. So again, it's the same shape as what we got earlier. However, the period here is instead of going out to 2 pi, we've now gone out to pi as we predicted up here. Okay, so our period is pi now, and the range again, the range hasn't changed. The range is still -1 to 1. Okay, so let's look at doubling that then. Remember, we've done cos of 2 pi. What happens if we double these values, double these y values? Well, we're just going to move from, say for example here, from 1 up to 2. So what we would end up with, instead of 1 and -1 here, we're going to end up with, let's say, we're going to end up with 2 here and -2. So this is 1 here and 1. So it's going to be the same shape. We're still going to end up with the same points. Still going to end up with the same points here. We're going to start at 2 here, here, down here, then here, and back up here again at 2. So the range has changed. The shape is exactly the same. So we're going to go down. Whoops, going to go down along here, around, up, and back up here again, and that's going to repeat over and over again. Our period. So the period here, the period is still pi, but now the range has changed. The range has changed now from -2 to 2. So we doubled our y values from our previous graph. So if you have a look at this, this graph here, this is our function f of x, and it's 1 cos 1x in this case. So it's just cos of x, the cosine of x. And it's as we drew earlier. We started here at 1, we go down through 90 degrees, or pi over 2, down here to -1 at pi, back up through 270 degrees, or 3 pi over 2, and we finish here at 2 pi. Now if I change if I change the a, this is b here. If I change b first of all, so I'm going to change this constant here, this one here. So change that to say 2. What's going to happen? Well, everything here is just going to squash in. So let's change it to 2. So if I move that out to 2, you can see what happens. As I increase that, it squashes in. As I decrease it, it moves out. So let's see if I can stop it here at 2. There you go, 2. So now I have a period here of pi. So we start here at 1, we go down to -1, and back up again here to 1. So now our period here is pi. We've doubled the angle, and we've halved the period. Okay, so let's just bring this back to 1 again. Let's see if I can get it stopping at 1. Oops, a little bit tricky here. There you go. Now this time I'm going to change a, which is this number here. So I'm going to double the cosine of x. So we would expect this to increase to 2, and this one to decrease here, if you like, to -2, and so on the whole way along. So let's move it up to 2, and let's see, oops, excuse me, let's see, down again, up to 2, 2.1, just over 2 there. You get the idea anyway. As we increase this value here, the range increases. So as I move it up to 4.1 in this case, just over 4 here, you can see where it ends up, and the same down here on the negative y-axis. So the range changes, and if I go negative, then it flips over to the other way. Okay, so that's basically what we did in the in this part here. Okay, so that's it for cosine functions.